So just initiated. Again, everybody for attending. This is Easy CNC with ShopTurn Setup and Programming. This content will be specific to the 828 and 840 controls, going through operation of system, jogging, setting some tools and offsets. We'll look at some of the content as we go through as part programming. Pollock, for those of you that may not be familiar with me, I am a dealer support specialist for the East Coast for Siemens, and I will be presenting today's content for you. My information is up there on the screen. Certainly, if you don't have a chance to write it down now and you don't have it, again, these recordings will be posted for further viewing, so you can always come back to it and get information if you'd like to reach out to me with further questions. These live seminars, they're new for us. We've been trying to get them out 1 month over the last few months. We've had it already gone through, and we have a bunch more coming up in the future. So today we're certainly doing the ShopTurn Setup and Programming content. Next one's going to be a little tight with the test shows, so probably won't have an opportunity to post the next one until October. But the next one will be shop mill, so it'll be very similar layout of content, but it'll be specific to shop mill for the 828 and 840. After that, we do a commonality between mill, program guide, CAD, CAM, and ISO mode. So kind of show you how all the different modes of the control kind of work together and how you can move between depending on depending on how you create your part programs, whether they're coming out of a CAM system, you're writing a G code at the control, or using shop mill. That'll be another one, and then we'll have many more coming up in the future. The content will be specific to any of the 3 part controls in our market, the 828 and the 808 control. Well, I did say earlier, but these recordings are posted on our CNC for You website as well, so you can access that if you would like to. So today, again, we're specifically looking at the 828 and the 840 platforms. We're going to take a look at CNC ShopTurn and apply it to a 2-axis turning machine. So we'll go in, we'll talk about setup a little bit, talk about how to set some basic part zeros, move the machine around, maybe create some tools. We're certainly going to go in and create a part program and even go as far as run it in the machine. You should get a pretty good understanding from start to finish of what it would take to set up a job, create a program, and run it in this system. What we're going to use when we get to our programming example, simple turning example, we're going to base off our part. We're going to create a contour as you see. We'll put a little relief. We're going to come in and thread on the part. We'll machine a 1" 8 thread on this part. Once we've done that, we're going to drill a hole through the center of the part to get you to see how the drilling cycles work. And then we're going to part off using our part off cycle. So when we're all said and done, we should have a complete part. I will keep bouncing back to a PDF that I have just to refer you back to the dimensional data as we start to put different features in. This webinar is probably going to take anywhere from an hour to an hour and a half. I didn't want to cut it short, so we'll get to it right now. So the first section we're going to look at is going to be jog mode. In jog mode, we'll take a look at the jog screen, the manual screen. So this would be the main screen where I can start to move the machine around. We can do tool changes. We can set some basic offsets. Come through, we'll talk about the TSM screen. Then we'll look at how to set a tool 0 and a part 0 through the measure workpiece or the measure tool function. Take a look at the offset table a little bit. Right, create a tool, and we could even maybe create a tool as we're writing the program. I do have a bunch of tools pre-created for us as well. So with that being said, what we're going to do is we're going to switch over to our SINUTrain software. And SINUTrain is basically a machine tool emulator. So it is the identical software you would see running physically on your control. It's all of the same functionality. So I can move around, I can set zeros, I can even go into one part program. It gives us a very good representation of what the machine tool would do in a offline piece of software. It is absolutely available in the marketplace, so if you'd like to purchase it, it is very available for you. The first screen or first function we were going to talk about is the TSM field. So first, before we go further, where am I at in the control? What am I looking at? Well, now we're in the jog screen. I'm in the jog screen. If I look in the upper left-hand corner, I see I'm in my machine mode, and my jog screen is up. Typically, this is usually the first screen you see whenever you power up the machine tool. Possibly, if your machine requires referencing, you may reference point screen first, you initiate a cycle start, or go through whatever manufacturer-specific homing process would be, and then if that's the case, the next screen you would see would be jog. Generally, it's one of those first screens you always see when you power up the machine. So the jog screen was created to allow you to start moving around the machine, setting offsets. Now, we did the functionality of this screen to be very aware of keeping things simple for operators, not bombarding them with a lot of cumbersome commands and instructions. So notice as we go through it, there's a lot of visually graphical screens that kind of guide you through the process of setup and moving the machine around. We keep having to go to like MDI screens and put in a lot of G code and M code functionality. It's simple. So with that being said, we're going to take a look at is our TSM screen. And that is the button in the lower left-hand corner of my display. What TSM allows me to do is TSM allows me to do tool changes, spindle commands. So if I want to fire up my coolant or something along those lines, a mister or whatever I happen to have attached to the machine, can load different work offsets and my unit of measure. So all stuff is very typical functionality that you would normally do through an MDI screen and a control. But by creating a simple little interface screen, it keeps the users from having to know and learn all these heavy-handed commands. If I want to do something as simple as just physically change my tool. If I look at the TSF window is just a quick representation of what's active at this point in the control. Notice that I have some plunge cutter physically loaded, maybe some keys or some spindle speed states. So come down, and I move my highlighter around with my blue arrow to my tool field. I can hit the select tool key in the upper right-hand corner and get us to my tool table. Table is showing me all of the different tools that are physically loaded in the machine currently. Say we wanted to spin to turret position number 1 and get to our CNMG 432, our 80-degree OD roughing tool. I can simply highlight that tool by moving up with the blue arrow keys, select OK. Machine fills out the name of my tool, and that's waiting for simple cycle start. By cycle start, will enable the tool change automatically for you. Now would do anything the builder prompted or wanted it to do for tool change. If it has to go to a retract location, it would go to that retract location. If they're just allowing the turret to spin at that point, it would do that. Notice in the TFS screen, now see my new tool loaded in my spun to that position, would have loaded any offsets that may be set for that tool, and I can now continue moving on with that tool. Just for maybe turning my spindle on. So let's say, for argument's sake, I wanted to start up my main spindle at 5 RPM, and I'm going to use my select key to define some kind of a direction. So maybe I want to move clockwise. I'm going to simply hit the start key. I see my spindle will turn on. My feedback will even show me that the spindle is spinning. Everything's running. So these are the typical steps I would use to spin the turret to some location, fire up my spindle, and get ready for maybe setting a tool. Offset. If I want to load up a work coordinate, I come in, select a specific work coordinate that I want to use, that I want to activate for, say, zeros. Cycle start, initiate, load work coordinate. Anything within the TSM screen will require a physical cycle start to then activate. I can also use this to maybe turn my spindle back off if I wanted to, by using the X with the circle through it, cycle start and spindle shuts off. You use the TSM screen to do a lot of your standard manual functions. Let's say I wanted to jog the machine around. So I can jog utilizing my axes right here. So I pick a given axis, I can the plus or minus key, I start to move the machine around. So maybe I want to move Z, I select Z. You'll notice it has a y-axis plus other axes. So this machine could support axes. This one's just commissioned for a couple. This was built to support C-axis capability in live tooling. Won't be going through that today, but we could in the future, absolutely. With that being said, may want to come in and set a tool offset. Very common occurrence that you'll find yourself doing when setting up a job for a. Well, certainly the first step would be load the actual tool that I want to add. Essentially turn my spindle on to some direction because I'm going to come in to take a little light cut or whatnot. And what I'm going to do is I'm going to use this. So tool allows us to come in and set our tool offsets. So once select the measure tool button, and it's selected by going blue, I just click that button. I can now pick in the upper soft keys, our upper right hand corner, the manual or the automatic buttons. I'm going to physically come in and manually set this tool, take a light cut on a piece of material. Automatic would be if I had a presetter, let's say, on the machine. We're going to go through just manually setting the tool today. I set the manual function. Your tool's already pre-selected. It knows what's in the turret or what's loaded, so it automatically defines that. Then probably, jog the machine or handle the machine to some location and take a light cut. We would go on our part, maybe mic up that diameter, and I would tell the system in the X0 field what the diameter I'm physically sitting at. So, you usually take a cut, move her straight back in Z, leave the X still aligned with that edge, shut it off, measure it, maybe found that we were at 2.5 inches. I type the diametric value, 2.5. The system will automatically cut that in half for you. I merely type it in and press the set length function. So before I hit it, I want you to take a look at our work field. The work is displaying our absolute positions relative to some offsets, some zeros, sitting at 23.68 right now. We hit length, and often it applies to 2.5. In control, when I set any offsets, we will immediately load those offsets. Same scenario, if I was to adjust the offset, maybe by applying a wear. So we were running this tool, we will maybe go to the offset table, go to wear field, and tell it that I'm big, so I want to reduce the offset by 5 thou. I come back out, didn't physically do anything with the tool or move the machine, but it means reflecting that offset. So whenever you're setting any offsets, you always verify that's the tool that's called up, or work one that's called up, that the display physically changed. If it didn't, you need to stop and kind of go back and figure out maybe what you did wrong as to why the tool didn't update or that offset didn't update. In this case, Z, maybe I came over, took a light cut in the base of the part. I could zero, I could tell it some small positive or negative distance depending on where I'm setting it. But I do the same process. I give it a value, I hit length, offsets change. You're going to do a lot with measure tool because you have a lot of tools to set up, very, very typical lathe. So here, I can stay within this screen. So let's say I was to move back, move a bit, and now I want to change to some other tool. Well, yeah, arrow back up to the T field in the measure tool field, we can initiate tools just like the TSM screen you just saw. Here, I hit select tool. We can arrow down to our finish cutter, say OK. That'll load it. We'll talk about tool names in a little bit when we create some tools. The tool is physically loaded. Now I just have to execute it by cycle start. It loads the tools. My offsets change because I don't have any offsets yet for this. Now repeat the same process. I would, potentially jog down, jog over to some location, maybe, and then give them and tell it what axis I'm setting. So if I'm just going to touch a out to a predefined axis value. I don't have to keep typing them each time. They set length and establish the offsets. And you just follow that process. Graphics will update depending on the tool that you've selected. So if you go to drills and end mills, you'll see it'll update to reflect that and try to give you a little better process of what we'd be expecting you would do to set this tool. In a lot of different ways to set up lathes. Generally, a lot of guys like to set up all their tool offsets either to a fixed datum or to just the part, and they'll adjust all the tools by applying some value in a work coordinate. So in our machine, you can do that by going in. I'm just going to put that string tool we had in before back in. Simply going to my measure workpiece field, piece, to move over to some location. So I was to move to some position, and I wanted to set a work coordinate value. So what the work coordinate value would do, it'll move all the tools the same amount. So if I had pre-established maybe all of my tools to the face of my chuck, let's say, and I'll move over one given tool, touch the front of my part, and then have all the tools set there. This is a good example of where I would use my measure workpiece field. I would move the machine back, touch the physical part, coordinate I want to work this, what I want the value to be. So maybe I'm hitting a 1, 2, 3 block or a piece of paper or stuff. I could tell it maybe a small value. Hit work coordinate. Display changes. Now that value didn't change for the tool offset. It actually applied to the work coordinate. So we'll go to look at the offset table here in a second, and you'll see where some of these values wrote. Other common things you could do within the jog screen would be maybe position the machine around. So tell it to feed to some location. Maybe to go to an X of 2 inches. Cycle start. The machine would run and do that as a commanded feed move. You can do rapid moves here. So you can just kind of move the machine around its work envelope this way. Do a basic stock removal screen. This simple can cycle tells you to do a basic simple stock removal. So if you wanted to turn some soft jaws, let's say, and I'm going to work on an ID set of soft jaws to write a whole program. I could fill out this one little event, to fill it out, and I have good numbers here. Then we'll get the key, and this becomes a little program. So I could legitimately hit cycle start, and this program should run. I didn't give it valid numbers, but it's a quick, simple way for me to do some basic cut paths. And depending on the machine tool you purchase and how the builder has configured it, we bring up a lot of these different can cycles up on this screen. Or our teach lathes, engine lathes that have the ability of running kind of manual and CNC like a hybrid machine. So they'll give you a whole bunch of different can cycles up this mode, and they work kind of the same way. Now, what we want to look at here as well, we were kind of moving the machine around and jogging around, setting a couple of offsets. I'll show you the offset screen briefly. Offset screen, I'm going to get there by hitting the hard offset button. I will, and the table is a tool list. The tool list is going to contain the tool, the offsets, and geometry that makes up the given tool. Tool is just how I can adjust small incremental values where. I also have my tool life management here. Magazine is more reserved for machines with like milling machines with random tool changes and carousels and whatnot. But you have the ability of that functionality here as well if it's a more complex machine. And then offsets is where all of my work coordinate or work offsets are set up. So I come in and I look at my GFT4. I can set number I got it wanted that coordinate offset set. Just like when I set my couple tools that are a distance from some machine location potentially to wherever I'm in the tool. If basing everything off of a gauge tool off a work coordinate, then these could potentially be just small incremental values from some datum to that tip. So with that being said, let's say I wanted to create a tool from scratch. You build one at least so you can see the mechanism. Certainly we don't have enough time to build all the tools for the whole part program, but if we can one or two, it'll give you a pretty good understanding of at least start of the mechanism. The way tools work in the SIN's world is you're going to potentially have tools sitting in a physical location. This would be a position or that is physically loaded in the machine, or they can be in what we call an unloaded state. We allow you to build or move tools from out of the machine tool to outside locations just by being in a loaded state, meaning they have a location to the left and they're physically in the machine, or what we call an unloaded state, meaning they still exist, but they don't exist in the machine. So there's 4 to make tools that are automatically in an unloaded state and then go through a loading process. Others do not. It's really kind of up to the builder how he wants to set up the machine. So let's say I'm going to build a tool in an unloaded state. Select New and a full tool library of different tools we support. We're actually just looking at what we call our favorite screen. So there's some very common tools you might want to use. You can go into more detailed tools, show you different kinds of curves, and right angle heads, and different die mold end mills and ball mills, drills, all sorts of different drills and taps we support. Learning tools. We do special probes and star probes and stops. There's a whole large list of tool libraries that are here for you. Most of the stuff you're going to use can be found under the screen. So let's say, for argument's sake, we're going to come in and create a standard turning tool. So it's going to be a roughing tool, so I'm going to leave the rough highlighted. And I have the orientations. Now, it may be hard to see on your end, but if you're close, you'll notice that the first one has a little orange tint, in relation to the other tools. I can move that orange highlight to each of these tools by using my arrow keys. This is how I define the orientation of the tool, how it sits in the physical machine. This machine is set up as a slant bed, as a rear turret. So this tool would represent a tool. If it was a front turret machine, then you would see everything would get flipped backward. Our icons, our placement will always represent or match the way the machine was built. The first position always represents an OD tool, but you might see the icon would look like this third one over here. What you'll do is you'll kind of scroll through, and you have a whole bunch of them. If I'm going to do neutral tools, I can get all my different orientations for my neutral tools. So we have, in this case, 8 different orientations I can pick from. I'm going to pick my first orientation, and I'm going to OK. I have the naming automatically turned on, so it gives me a rough name. And this is probably one of the first things that guys notice that's a major difference from us to a lot of our competitors, is the fact that tools do not have to be numbers in our world. Can be. There's nothing wrong with being a number. You can build anything you want. I like it because I can build in kind of your comments or notes right into the name of the tool. So let's say, for argument's sake, I wanted to build a 35-degree tool. I tell it it's a VMG, and maybe it was a 332 in radius, and I happen to know that is an oval tool. This would be a normal way for me to put in some different information I have right in the name of the tool. Breaker, you get elaborate. We support quite a few characters within a given name. You type name, whatever you want. Letters, we support anything you there. Even you see forward slashes in some of mine. We can do special characters. Hit enter, and then it moves the highlight over to the X length. Turn the control would also be the yellow input button here. Length for X and the length Z will get filled out with the set length functionality. You don't have to put numbers in there unless you know them. If you're presetting tools or have known data, you can type them in directly. That'd be my radius. Number 2 rad, so that would be 31 radius. So I'm going to type it. Direction. Now to figure that out based on the orientation I chose, if I wanted to flip things around, I could change my primary cutting direction. 2 primaries for this tool would either be down or to the left. You'll notice if I put the wrong cutting direction, we can hear on the insert to say, hey, things aren't quite jiving. So in this case, I'm telling it to have a left-handed pull but cut to the right, which doesn't like that very much. So we'll do a standard left-hand tool, cutter direction. The next field is our relief angle. That is basically my clearance. If you look at this insert picture to the top of the screen, it's the angle distance. So it's always added from 90 degrees. So I have a 5-degree relief. I'm going to put 5. If I have a 3-degree relief, I'll put 93. 7 is 97. So you're going to take 90 degrees and then add whatever that relief angle is to it. We have the physical insert angle. I know this to be a 35 degrees instead of being MG. And I have the IC of the insert, so we'll say it's a 1/2-inch IC. See is that inscribed circle in the insert, right? So that you can kind of understand how big an insert is. From there, there's a couple extra fields. You have your standard cut direction for this tool. So if I was inverting the tool or something like that, I could flip it over. I have my physical coolants. And you may or may not see multiple coolants. It really kind of depends on if the machine was built with a couple different coolants. So a lot of times I'll just see one. That'll be a standard flood. And maybe the second's a high pressure or wash down or something along those lines. So that's all filled out. I'm set. My tool is created and defined. I have all the information I need to know about it. Now in this case, the tool is unloaded. So we know it exists, but it's not physically in the machine. So it's time to mount the tool in the machine. I want to put it in the machine. I'm going to make sure this tool is highlighted anywhere on this field. It doesn't matter. I'm going to use the load button on my vertical soft keys. Load allows me to say, hey, I'm going to put this in the machine right now. And where do I want to put it? So maybe I knew that I want to put it in pocket 16. I type in, say, okay, moved up. Do I now have to actually mount a tool in the absolutely. This is just a mechanism for us to manage the tools. What is, if you're dealing with a lot of tools, you're breaking down setups all the time, I can come in and say, hey, I'm not using the 3/8 MO right now. The tool is still a valid tool. I'm potentially going to put it back in the machine at some point. Just highlight the tool, unload, and see, I didn't delete the tool and lose its data. It's just sitting in an unloaded state. Tools can I support in this screen? It's up to the builder. It is builder selectable, but most time I see most builders will support 99 tools. So it's however many locations we have here, and the rest of it until it equals 9. But we can support really up to a function of the builder. Now, when taking a look at tools in our system, is what we call multiple cutting edges. So in the world, you can actually create up to 9 unique offsets for any given tool. Typically, when using this type of functionality in maybe some competitive controls, you would have had to sacrifice another offset number to use to be able to do this type of functionality. So, maybe I had offsets. I have to say, okay, well, I'll use offset 20 to match with fun when I want to have a down offset or have a different offset. In our world, you simply select the edges function. And edges will be to create a whole new offset. What I do is I select new cutting edge. Now I get a second one. Now no number. This doesn't mean it's unloaded. This means that these two are associated. In this world, when you're dealing with multiple cutting edges, you will get a new number under each field. And this is how it gets called up in the part program. Number from D1 through D9. So you see a D number larger line, because that's the number of offsets we support. And then from there, it always match this number. Completely unique tool. It doesn't even have to be the same physical tool. If I had a little gang tool set up here, and I knew that I had a turning tool, a threading tool, and a part-up tool on a little gang set, I could do that right now. I could come in and say, okay, well, my second cutting edge is going to be, or my second cutting edge is going to be a part-off tool. Now, the one thing it doesn't let me change is the name, because it's linked to this turret position. So it's only one name. So you might want to call it universal or something like that. But now these offsets are completely unique. There's no association. In this case, now the width, instead of the angle, this is my insert width. So if this was a 100,000 wide grooving tool, I would just type 0.1 here. Oops, excuse me. I type 0.1 for grooving tool width, and that would be some of the parameters you'd use for a grooving tool. So we're now going to jump back over to our PowerPoint here a second. And we're going to take a look at this area we're going to explore in this seminar. So next thing we want to talk about is our program manager. Start to see some of the functions you can start to use to set up a job, jog the machine around, maybe create some tools. The program manager is an area for you to manage the programs in the machine. You're going to get to the program manager area by selecting the program manager button. That's typically a hard key somewhere on your panel. All of the hard keys can also be accessed via soft keys by simply hitting the menu select key. So if you have some kind of a custom front panel or whatnot, which is very common in our controls, you want to just find the menu select key. Once you hit menu select, you will see those soft keys come up. We'll look at that in a second when we get to the live portion of the demo. Program Manager, I'll get a list of directories and areas where I can start to save programs. So we'll take a look at that. Ability of creating directories, creating different types of programs. So you're going to get a chance to see how to physically start and initiate a ShopTurn program. Setup data. So all those fields or features you saw within the tool table can be saved as a physical file. So not only can you manage part programs specific to a job, but also the tool data that makes it up. And the tool data is all the tools as well as all the offsets, all of your work offsets as well. We can take a look at that. Once we've created a part program, we're going to go into the ShopTurn programming interface, and we'll start to take a look at all of the different kind of elements that make up a ShopTurn program. First thing we'll see is the program header. That's always going to be that first initial screen we always see when we first start a program. And there's a bunch of basic parameters we'll fill out in there and explain to what they do. We're going to get to the event editor. This is where we actually start to give the program some depth. This is where we start to tell the machine what it's going to do. We're going to first come into the editor, and it'll basically be blank. And then we'll start picking different options using our software buttons like turning or turning to go to a defined location or operation. Chance to see some of the can cycles. In this, we're going to use a basic turning cycle for phasing, and then go into our contour editor to machine in a regular shape. Once we've programmed up the part, get a chance to take a look at it in our 2D, 3D simulation mode, and we can start to look at cutter paths and different feature part, good in 3 dimensions, maybe cut it, to start to look at some of the internals, especially to get to some intricate internal work. It's a way to be able to see what's going on inside of the part. And that gives us now an opportunity to go in and physically explore some of these features. I'm going to select SINUTrain again. It's going to put back over to the SINUTrain, this demo. From here, like I said, I'm going to use the Program Manager to get to Program Manager. This button will get me right there. But if you can find the button for some reason, just find wherever the menu select key is. Menu select is always somewhere on a front hard panel. That's a must as far as all buttons. Usually 2 you'll always see. Menu select and menu select, and these are different soft buttons for it. So Program Manager here, there's the software button for Program Manager. Sometimes we change names on a function. At the end of the day, as long as the icon matches. So if you look at the parameters button, the second one over, at the offset button, the hard button called offset, and you see that it's the same icon, goes in place. We happen to use a different name on the software button than we do on the hard button. That's all. Same thing with diagnostics or alarm. Hit the alarm button, let's go to the alarm area. If I hit select, hit the diagnostics button, it goes to the same area, the alarm area. You can hit Manager to get there, or you can hit Menu Select and then Program Manager. This is the program manager. So this is where all of our programs reside in the control. What we're seeing is the NC directory. So this is active internal NC memory machine. With the memory, we've kind of set it up to feel very similar to like a Windows environment. So I may come up and see my 3 core folders: part programs, subprograms, and work pieces. I can use my blue arrow to move cursor up or down, or my left arrow to expand or compress different folders if I want to look in them. There's areas where I can start to find where part programs reside. Now, programs in the part program folder can have and must have an MPF extension. That stands for main program file. You can't have any additional different types of programs here. This is just a simple folder for you to start creating part programs. If you create your own subprograms and group different part programs and have all kinds of different files and whatever at the machine, you can have PDFs, you can have them physically at the machine if you wanted to. All that needs to be done in the workpiece folder. So in workpiece, I have the ability of selecting new and a directory. Selecting directory, I could say this is going to be my demo. Whatever. When creating folder, I can use letters, I can use numbers, the same thing with file names. But other than that, the only extra character we support, especially in a file name, is underscore. In fact, if you try to do space or a minus sign or an asterisk, we'll tell you that we don't support that character. So when creating names, it's either a number or an underscore. When creating a directory, I'll see it created this demo program directory. If I expand it, there's an in it yet, but not bringing programs in or out. It always comes up in this area is how do I move programs in or out? We have a bunch of different ways to move programs around, or where the programs can be residing, shall I say. One simple way to move them around. That's places like our USB, maybe a PDF card, maybe could have a mapped drive on a network and show up like a button with my local drive button here. So wherever I want to go, I'm just going to select that device. So if it's a USB, I would plug it into the machine. The USB button would go black. I would hit it and show me potentially whatever's sitting on that USB. My local drive happens to be a mapped drive I have on the machine. So, in this case, maybe I wanted to come to a specific file, like example, say, some program. Find whatever the file is that you want to bring over, and it's now as simple as using our cut, copy, paste commands on the vertical soft keys. Select copy, go over to wherever you want to place it. In this case, I'll place it in my demo parts. Hit paste, the file. As you edit files sitting in remote spots, you can even run them from there. So if you wanted to, you could run a file right from the USB or from your local drive. We tend to discourage people from running on the USB because it's not the most robust or stable of connections inherently in a USB connection. It's got a couple of pressure pins, but it can absolutely be done. It's concerned you could treat it as an external drive if you wanted to. If I wanted to get rid of a program, I can expand my vertical soft keys over by hitting the double arrow button at the delete key. Warn me, of course, and then it'll delete that program from that directory, not from wherever the source was. I'll go there if I wanted to. In this example, we create a new part program. So I'm going to select new, and I'm going to create a name. So ShopTurn, whatever I want to call it, I'll call sample 1. My name, okay, I want to make sure ShopTurn is highlighted, and I'm creating a part program. The first step in the part program is to fill out the header page, and that's the page you're physically looking at right now. Question 1, what's the unit of measure? Am I using coordinate or not? To see, that's more common in machines supporting sub-spindles or live tools and whatnot. Gives us the ability of actually writing into the work coordinates from our part program. Generally, I'll just leave this at no, especially on a basic 2-axis machine. Blank allows us to describe what the stock looks like for simulation. Is it cylinder, type, Is it some kind of square stock? Is it a hex stock? So a lot of different support of different material. We define the dimensions. So in this case, I'm saying that my OD stock's 2 1/4. A little bit of positive material. So I'm establishing myself. All of my tools face my part to be 0. Negative into my part is going to be a negative number. Anything in front of my part or clear of my part is going to be a positive. So I'm just saying I want to leave 25 thou positive material to get cleaned up with my basing tool. What's the rough overall length of the blank? This is always going to be greater than ZB, which is how far from the jaws or the collet face is the part sticking out. This is important. This is going to give me an indication if I get too close to my work holding, potentially have a crash condition. How do I want to pull off the part? When you get into maybe more complex work like ID work or back turn work, you can go and have a bunch of different retracts. If a simple OD job, which basically in the case we are, I'm just going to give it a basic retract or a simple retract. The retract values can either be incremental or absolute. I personally like to use incremental if I can, except when I get into an ID boring application. Then sometimes it's nice to give it the smallest diameter that bar could bore to. In this case, I'm just leaving 100 thou off of any surface that I can retract off of. Careful, if you set this to absolute, remember absolute location, so then have to become a value greater than the part stock. If I did that, I could be errors or colliding into the part. What is unique to our control is the ability of defining the tool change location in the part program. So this tool change point is where the machine will physically go to tool change, and this is also unique to just turning in our world. The mills is different. So in this case, I can define 2 options. I can define a machine location. I can use this teach position to say, hey, I just may park the turret in some location. If I'm happy and I know it has full clearance to start spinning all my tools, I can simply say teach in, and that record wherever the machine is physically sitting right now. I can use positions relative to work coordinates, just throw some values relative to that. I don't have numbers in this machine, so I'm just going to throw in some simple offsets. But on the physical machine tool, a lot of times I like to use the machine button. It's a more a permanent location. It's very cool. Next, S1, that is a maximum RPM. We're going to allow the spindle to run at while in the program, so maybe I don't want to go over 2,000 RPM. Safety, how close do I want to get to a part before feeding? So I come with 50,000. I'm doing milling. I want to climb mill or mill. Instead of climb mill. If you do milling, you won't even see this option. This page. You get and the event there. I just saw a question came in. How do you access this view? I'm not sure which view he's speaking of. Pareto. An opportunity. The one with the block form, I think you're talking about. So in the header, it's the blank. I believe about the block. So it's just under the blank field to the block for the block form. Great. Well, this gives us a good opportunity to see how I can make editing changes. I had accepted it, and I have my event up on the screen. If you want to access that event to make changes to it, you simply hit the blue arrow to the right, get event back, come down to whatever field you want to change, hit accept, and it's it. So in this part of the program, just to show you guys real quick, to refresh your memory on the shape, we're going to face off the part, use an OD tool, titanium tool, come in and machine this OD, and then come and do a few different things. So my step would be to face off the part. When you're programming, the height is always going to be just above wherever it's going to physically insert this command. Keep your highlight above. If you would move the highlight down to maybe end the program, you would have to move it back up because it would tell you that you're not allowed to insert after that point. So a key highlight at the top of my header, I go over to turning, and turning, you get an opportunity to see a bunch of different cycles we have for you in the control. Time allotting, I certainly don't have enough time to go into every one, but once you see one or two, they're pretty self-explanatory. So the first cycle we're going to use today is the stock removal cycle. So that's the cycle in the upper right-hand corner. And stock removal allows me to do is it allows me to take some multiple cuts, be on the face or the OD or the ID, for these atypical shapes. So a standard square part, no radiuses or chamfers, a part that has some radiuses or chamfers in the corners. You have some angles and radiuses and chamfers. I can define in the cycle if it's OD or if it's back turns. You get pretty elaborate with shape. Use this for facing, so I'm going to do a basic standard, no corner or chamfers or anything. First, select my tool. So the first question the system asks is, well, what tool am I using? It's retaining the data from the last time the event was programmed. All fields are what we call user definable, meaning we don't decide what your defaults are going to be. They just retain whatever state you last left them in. In this case, I want to make sure I pick the appropriate tool, so I'm going to hit this tool select key, and that's going to bring up a reference of my tool table. See the tool here? Great. I could just arrow up to that tool or pick it, in this case with my mouse. Or if I maybe didn't see the tool here, I may want to hit the tool list button one last time, put me all the way back to the tool table. In this case, I do see a little indicator here. That's just because that was the tool that's staged at this point. Highlight the tool just by moving it to that point, and then you press the to program button. What it'll do is that'll just fill out the field for you. Type the name out, absolutely. But when you're adopting or naming terminology, it gets kind of cumbersome to start typing in all of these fields. So that's why we have this mechanism. Just select, find tool, say OK, fills it out for me. Okay, I'm using my CNC degree diamond. It can be defined as feet per rev or inches per minute. I can toggle that. I'm going to keep it per rev. I can toggle between or constant surface feet. Toggling. I'm doing that with the select key. In the machine, if I'm running or finishing, so I'm going to take multiple passes, or I'm going to go right to these dimensions. What's my shape? Is it OD? Is it ID? So I can select key. And these couple of options. Face, or I turn it. This face off, so I'm going to click. Then you give it your basic dimensions. Said my rough stock was 2 1/4, so I'm giving it my rough stock of 2 1/4. I was 25 thou of rough material on the front, so that's where my D0 is. I'm starting 25 thou away from my part. I'm going to end when I'm done at center of the part. This is X1 is my ending diameter, 0, because I want to face all the way to the center of the part. And when I'm done, I'm going to end at Z0 or Z1, which is an absolute position of 0. That's going to be the face of my part. And with the D, I can define how my depth per pass is. So in this case, I'm going to take 15 thou. So I'll take a 15 thou pass and then take whatever's left over and for a final pass. And then I have a little material for a finish cut in the U field, the UX or UZ. You see a U, that means finished stock. So a lot of page, and as long as you did everything properly, you'll have the accept key. Now, if you put a funny value, let's say, feed rate's too large, what is you'll lose the accept key, so you can't do the next step, and we'll even tell you, right above the key, what we think is going on. So in this case, straightforward. Feed too large. Oh, I use 1/2 inch per rev. That's quite a bit. Down, I see the accept key, and I'm good. Usually, if you can get to this point, you're pretty close. Certainly, we don't necessarily know what if your dimensions are correct, but the structure of the cycle is correct. At this point, if I wanted to simulate, just to get an idea of what's going to happen, I can simply hit my simulation button, and this tool will come down and just face off my part. This is your first opportunity to see the graphics. Tool come down. My show path turned on, So I see it come down and face off a couple pieces. I can on or off by hitting the double arrow key on my verticals and just show path or not. Yeah, I want to continue on the program. I simply hit the edit button or simulation again. Either one will take me out, puts me in my editor. In this case, we're going to continue to move on. So if we look at the shape one more time, see that I faced off the part to size, and now I want to create this contour. So I'm going to go in, and I'm going to actually draw this contour. Now, I'm going to start right at the 1-inch diameter and put this little chamfer here. Then I'm back. I'll count this field. So you'll notice, really on this detail, I don't know some absolute positions, but I roughly know how in this relief's going and how far back, at least before my arc starts. And I'll feed up and feed around. So I've got a few different things going on in this part. If I want to go our contour turn functions, I need that button right to the right of turning to get to irregular shapes. So the turning handles all my standards. So grooving all my full shapes, square shapes, whatnot. But when I get to any irregular shapes, I'm going to use the contour turn function. With this, I can do basic stock removal or basic turning for OD or ID. It's all set up right within this cycle, so you get a chance to see this cycle here. I also can do irregular grooving, or with the plunge turning cycle, we can do irregular directional turning. So take a look here. I'll come to the help screen. Here the tool would feed over, feed down, feed over, and the part with like a groove turn combination tool. What we're going to do is we're going to do simple stock removal. To these irregular shapes, first you need to do is draw the shape. And that the first button in the upper right-hand corner is called New Contour. New Contour, and we type in the name of the contour. I'm just going to call it something simple, OD. Once I've typed the name of the contour, I'm going to start to give it some elements or drive the shape. So these I'm getting right off the print. I said I was starting, or I had a 1 inch and Z0. That's going to be where my thread starts. I do have a chamfer that leads up from the face. So tell this is a transition to the start of the element. And I tell it the chamfer size. I now see the first point is sitting out at 1 inch. I use these icons on the right side to kind of shape. So I'm pulling back. So I'm going to say Z -1. I don't have anything happening when I get to the end of that, because I'm going to go into that piece. So I'm going to simply hit accept. Now my first chamfer, and my back. It's drawing up top above the 0 because this is a rear turret machine. If this turret or front tool post machine, this would be a mirror image of itself, and it's drawing on the bottom side. So it's always going to represent where the tool is. So when I want to do that relief, I'm going to go into a 2-axis move by hitting the X button and just give it some information. So if you look real quick, detail, see that I'm going to move in incrementally 90 thou and move over incrementally 200 thou. That's the data that I'm going to give it. I come in and I'm going to toggle select key, both these fields to be incremental, and you can mix and match these. Both numbers don't have to be incremental. You can have one incremental, one absolute. Both said we're moving in 90 thou and we're moving over 1, 2. It calls for that location. I hit accept. We're in. Now next move, I'm going to do this as an arc. So I'm going to simply pick the arc to fill my arc. I happen to know the radius is an 8.125. Any fields will support math, so I could pin 8 and hit my input key or on my keyboard, my enter key, and figure it out. Look at the endpoint on the print. Now, my print wasn't that clear. So I don't know where the endpoint of the arc is in X, but I do know in Z it's up against that wall. So that wall happened to have been at -1.375. I don't know the absolute center of the arc, do know that the arc is tangent to the previous element. Simply hitting this tangent button, telling us, hey, the arc is tangent to that previous line. Now, example, see two little dots, and I have this orange arc. And if I hit the dialog select button in the upper right-hand corner, I can get a small portion of the arc or a portion. When it mathematically calculated this, it said, well, on the end point that he told me of inch and 3/8, I could be going through that and hitting the arc a second time with that line a second time, or it can be stopping the minute I hit that line. So in this case, I want to stop the minute I hit the line. So I'm going to pick the shorter of two. So my smaller segment is orange. And simply hit the dialog accept. If you pick the wrong feature, you can always go change selection, get right back to it, and select a different one. I came in, I selected those points. I'm now going to accept it. I arc. From here, just walk around the rest of the shape. So the part I happen to know move out to a 1.75 diameter. Now, at the end of that move, it does have a radius, so I'm going to use the end corner and tell it I'm going to radius to whatever comes next. I have that radius here until I give it next move. Next move happens to be going back to 1'7", 50. See the radius come in, I move back to 1'7", 50. And do a 2-axis move. 2-axis move is going to go to a diameter of 2 1/4 in this case, and I'm just getting these numbers right off my print. 2. I'm going to come back along the part. Now my part length ends at 2 1/4. I'm going to part it off. I'm going to want to go a little bit beyond it so I don't leave a ridge or a radius. I'm going to say go to -2.3. Hit accept. Now, question. At this point, or do I want to do a pull-off move? I get this point if I'm happy with this. But the only thing you want to understand, you have to be aware of, the tool is going to come up and along the surface. Cutter comp is automatically enabled. I don't have to do any fancy things to turn it on. But since the system see this to be the last move, you automatically go beyond that point by the use of the cutter. So in this case, foul. As though that's not going to potentially hit anything, I'm going clear. I can stop right now. Sure that this system is going to collide into my chuck jaws or anything that's coming beyond this. You know that I can't let this cutter go any further past that. One final move off on the X, and that'll kind of gate the shape. I'm going to now hit accept. Done. You say there. There's this little open-ended bracket that tells us it needs a little more information to decide which cycle I'm using. So I'm using my stock removal cycle. Stock removal, I'm going to flip this to roughing. I'm going to get my tool. Do I have to give it my tool each time I come in here? No, tools are modal, so I could leave it blank if I want. I give it some speeds, give it some feeds, rough finishing. Am I on the outside? Am I inside? Am I cutting the face? Am I following contour? Doing stuff. Interfacing, outside or inside. Depth pass. How many leave for a finish cut? Now, I left this at a single diamond. That just means roughing. To a triple, it'll just finish. Or plus a triple, it'll rough and finish with the same tool. To do that, I actually want to go with a different tool and finish it. So I'm just going to rough it. So the material I leave here, the 10 thou to 5 thou, will not be taken off until I come in with the finishing operation. It's kind of a neat field. That's called an interrupted feed. Here I can give the system a linear distance, and once it becomes that distance, it'll pause the servo enough to break the chip. So kind of like drilling cycle. So I held it, 0.250. So it's moving Z every 250. It's going to stop the servo enough to break the chip and then continue cutting. Materials. BL is what controls what I'm really machining from. A lot of people think that I'm machining from the solid I set up in the header page. You're not. All in the header page is just simulation. This right now is what controls where the machine starts machining from. Simple cylinder is saying, hey, look at the shape that I just drew, and I'm just going to assume or I'm going to be machining a basic bar type of routine like you see in the graphic. And I can apply a little additional material outside of the shape if I start machining away. So these two values at 0, 0, it's going to simply cut based on the shape that I drew. If I want to start further out, maybe all of a sudden my stock changed, I have to go change my headers or anything like that stuff. I'm just going to move this one number out. That said, however, I can also do allowances. So a pre-machined part or a cast part, I just tell it how much material there is based off the shape, and just machine where it needs to. Allow it as drawing a separate contour to represent the stock. And again, the machine will just machine where it's to machine. So contours, or I have cast parts, I can do that by using the contour feature. In our case, we're going to do a simple cylinder. I want the system to go in and try to turn that relief. Well, I'm going to let it try to turn that tool, and we'll see what happens. So I'm going to yes, you can try to go into any reliefs. Do I want to come into it? And the question in the cycle is, do I want to limit it? Limiting allows you to reduce the amount you're machining by kind of a box. So a good example of this is, let's say we had a large bar with a steady rest in the way, and I do the whole shape, but I can only go really a foot back, not the feet I drew. You could create a box, and it would not go anywhere further than the provisions of that box. We need to worry about it. We leave it at no. Select accept. Now, if we go simulate, we start to see where we start to come in and cut with this part. Now, keep an eye on when we try to go into the relief on this operation. You'll notice that I get a small diagonal move in. You always have insert checking and gadget checking enabled. The system is never going to what it can with that physical tool. You'll get as much as you can, and now it's going to leave this material for you to figure some other way out. Really, if this wasn't a lot of material, I might just go into a finish cycle and let my finishing tool out. An option maybe would be pick a different tool to rough with. Maybe you want to rough with a 55, not an 80 the whole time. Or if you have the option, and this is an option in our control, you can use a function called residual material. What it does is it gives you the ability of going and picking a different tool. So to pick my 50-degree tool, give it just like you saw before, some parameters like depth of cut, finish amounts. But when you hit accept, it's going to say, okay, I'm going to figure out everywhere that CNMG could not fit and machine it with this MG. So you see the system automatically figured out that my roughing tool couldn't fit here. So let's go in there with this finishing tool and that portion. So it out of regular shapes, it allows you to quickly and proficiently handle areas where cutters can't fit. I'm going to want to go back to the turning cycle, back to stock removal. I'm going to go to a finish, take that final finished material out. And since the tool blank, it's going to finish with my DNMG. So one final simulation on that, and you're going to see the shape. Go into 3D if I wanted to simulate it in full 3D. You can rotate and pan, do all kinds of crazy stuff. Zoom in. There's little keys to do all of this. I'm just using my mouse because I'm cheating. But you have a lot of different controls as to how looking at a physical shape. I'm just a side view right now. Next operation, look at the print. We've done the whole thing. I want to put the thread on it. So put a thread on it, drill a hole, and then we're going to part it off. So the thread, remember my highlight, I'm always in below, so I just leave the highlight on this last line I did. Over to turning, and then the threading cycle by picking the threading button, so vertical. Threading, I'm going to pick a tool. I already created a tool. This was like a notch style Kennemental tool. and define a table if I want to pick up a specific table, or I can just tell it that I'm going to define the thread as a total command, meters, or threads per inch in inch mode. If that and just changing over the length of the thread, you can tell it that, and it'll change. We also support tape threads, and vehicles can support OD or ID. And it's called chain threads, where the pitch can change and the shape of the thread can change over the course of the part. Standard straight threading. Fine. In this case, I'm doing an 8 pitch. You have the fraction. If not using the fraction, you cancel the fraction out just by giving it like a simple 0/8, let's say. Tell it the RPM. Now, we can do that. It's very unique in the system. Is you can thread in either RPM or constant surface speed. This is dependent on the builder whether they support this or not, but the control absolutely does support threading in constant surface speed. Another thing you can do in our controls is we do variable speed threading. We're going to adjust your spindle speed live while you're cutting the thread. We do not cap the spindle speed. Feed rate obviously is a function of the pitch, so that doesn't matter really, but it's always going to be 100 during the thread. But this over is absolutely live. Some builders will not all this functionality based on their performance of their machines, but as a control is concerned, it can absolutely, as a standard function, allow you to adjust your spindle over while in thread. Aggressive or linear cuts. Aggressive is going to reduce the cut per pass as I get it deeper in. Your ID, and then you just fill out the dimensions of the thread. So it's the OD. Where does it start? Does it end? Advanced do I want to give it? So usually I'll use about 1 thread rev. So on an 8-pitch thread, that I might want to give it just about 1 pitch for its start. So it means it's going to start 100th out away from the part. R, do I want to do a chamfer leading out? If I set to 0, it's going to cut it as far as it can and then rapidly clear the back of the thread. The thread height, feed angle, and AP can be toggled between an AU. I like to set it as an angle, and I'm using a 30-degree feed angle. Depth, how much finish pass, number of string cuts, back off VR. So my pull-off, I usually like this to be a little higher than the thread height. It's not really all that critical, so it's because the value off the major. Having multi-lead threads, yes or no leads. And do I want to control my starting angle of my thread? So I needed to time the thread in relation to something I could. Fill out the event, it stores it. In this case, I'm going to maybe go in and drill the hole so I can jump over to drilling. If your machine does not support tools or live tools, what we get is drilling centric, because I'm drilling always in the center of the part. Tooling, and we'll go into live tooling in a later section in our series. Then you'll get to start some of these live tool functionality. So we're just going to do a simple drilling centric. You can do drilling or tapping within this drilling centric. It automatically supports chip breaker, chip removing cycles. But if you don't have PEC drill, you just create it where your depth and your PEC are the same value, and you're drilling it. Fill out the page. You hit a drilling cycle. In the drilling cycle, we do have the ability of compensating for the tip or the shank of the tool. In this case, I told it go to 25 to 225, 2.25. It'll go that plus whatever the projection of the drill is, because when you create drill, you also tell it the tip angle. That's going to be a part off function. I'm then going to go back to turning, off option, and then for this page. So in this case, I'm going to select my plunge cutter, and when creating grooving, you'll not only tell it your standard information like your corner rake, because we can profile and finish with the cutter. You give it the insert width and a rough length of the overall insert length. The insert is not that critical. The width is obviously critical. This is going to automatically compensate for the backside of that tool. You don't do it. It'll figure it out for you. But you got to give it the appropriate width right here. Create some spindle speed. The max RPM I'm allowing the physical spindle to go because in case I happen to be running constant service speed for part off. What's the OD and what's the total length of the part? It'll likely add the insert width to this value because it knows that this is a part off part. And plug in chamfer or radius. FS represents chamfer. And if that was an R, that would be a radius. So I was doing a 50 chamfer at the back of my part. This is kind of nice. This is our reduced speed and feed for our part off. So, we've all had that scenario where I'm flying down the part and it pops and it's going real fast and it flies across my top or misses my parts catcher. So this is saying at what diametric location do you want to now slow down the spindle and the feed rate. So here I'm getting to be to an 1/8 in diameter. I want to reduce my feed rate. I want to reduce it to a straight RPM at a given RPM. And then where do I want to end at the very end of the part off cycle? Off the page, you accept. So now we have a programmed part. So I do a final simulation. Just keep doing obviously operations as you go on your specific jobs. But the mechanism is really where you want to kind of get from here. So we rush it, thread it, the drum and drill it, and we part. If the internal, see that drill, I can go to further and select half cut view, and then it's a sectional view. Have this up, so I could have had that while I was machining the entire part, and then I could see the cutter come in. Control the speed at which it simulates by going program control, maybe using the overrides up or down, or just hitting 100%. It's because you can really gain a lot of control when you're simulating. So, if I slow it way down, I can just see what's happening. You can feed, you can, cycle stop, you can reset, you can do a whole bunch of things. Now, this is all independent of the machine running an auto. Do all this functionality while cutting another part. So you can concurrently program, concurrently simulate all this stuff while it's doing another task. Okay. So for presentation, the last section I'd like to talk about, we'll just take a look at it pretty quickly because we're getting a little late on time, is our auto mode. So I would physically go to run a part program. So some of the things we'll talk about is we'll talk about our box field, our distance to go field, bringing up simulation in auto mode so you can use the same simulation, but that's a current simulation to where you are. Maybe starting in the middle of a program, how would I start at some point in the program? When we look at auto mode, get into auto. Well, one of two ways to get into auto. I can access auto right now by hitting the execute button in the lower right corner. In my program manager, I hit the execute button in the upper right. Both functions will do the same thing, and what they'll do is they're going to put me into auto. They're in auto. I was spindle running the whole time. Put me into auto and loaded the tool. See, sample ones or loaded the program into memory. Sample ones are here, it's active. I didn't have to do that as a separate step. It's all automatic. I just say I'm in this program or I'm highlighting this program and I tell it I want to execute it. Hit the radio button for auto, then it would have gone into auto with whatever the last program, or it wasn't the last program, just a blank auto area. So I do have to physically either go into the program or use execute from program manager. I do want to be aware of where the highlight is, because there's one way to start in the middle of the program. So while I left my highlight on cutoff and I went into execute, it stages and tells me block search mode has been activated. mistake, because I really just want to start from the beginning, just simply hit the reset key and it'll run the program. Start from there. Certainly I could have hit cycle start and it would have started. If I'm starting from the beginning, it's simple right now. Initiating cycle start, it would start machining my part. I can control with my overrides how fast it goes. Say I want to see kind of results of these different cycles. Well, if you hit the blocks, you've got all of the resulting lines. A lot of people, they get concerned when they see conversational type of programs because they don't have a good idea of where the machine's going to next because the cycle figured it out. Hit your basic blocks and it'll bring it up. A timer parts counter, so it'll give you cycle time, time remaining. You can do work count if you want to. It'll track your different work pieces, where you are within a production line, that kind of stuff. And control the system in the program control. So program control allows me to maybe enable options. PRT is like an axis lock mode. So the system will run, but the servos won't really move. Dry run. I want to run it. I don't need a part in there. I just want to run it in the air real fast. I can initiate a dry run mode. RG, reduce rapid traverse. Say I got a new machine or a really fast machine, and I'm proving it apart, and the rapids are just too quick. I can select that with a little RG0 whenever any of these are active, because the panel may not always be up, but they're active. So right now, I know the run is on, because I see RY, and I know the rapid reduction's on. So if I do it, I can go on or off. Single blocks. We have a couple different modes. The two most popular are rough and fine. So block fine is what we're all kind of used to. That means every time I'm going to do or execute some kind of move or command, I got to hit single block. Block rough will allow non-motion commands to pass through, will allow can cycles to kind of go through, like if I'm in the middle of a peck drilling cycle. It'll allow the peck drilling cycle to complete, but not move to the next location, let's say, and hit cycle start again. That gets kind of handy. A bunch of different ways for me to control how the machine's going to react. If I want the simultaneous record on, I pick up simultaneous record. The graphics, now when I initiate cycle start, I'll see the cut, and it's a real time. The simulation runs a little quicker, or shall I say, the SINUTrain mode runs a little bit quicker normally would in real world. But you could, this functionality would allow you to see what's happening on the machine at the same time as running it. Okay, so we covered a lot of material in certainly a short time. Everybody hanging on there. I want to now open things up to our Q&A panel. So we do have that window, but sometimes it's easier if you guys use the Q&A panel for me too. Any new questions that you guys are going to pose, if you go to a little pull-down toolbar and see Q&A, just click on it, type the question in, and then we start to talk about some of this stuff. With that being said, let's open up the floor to any questions. So we have our first question in. Is it possible to convert a ShopTurn program to a G-code program or vice versa? It is not. ShopTurn programs will only be ShopTurn programs. You can certainly bring up basic blocks like I showed you to see those resulting codes. But in a scenario, when we built ShopTurn, we built it at the same time really as building the program guide in this interface. So it was like an add-on piece of software where we had to translate it out because in the back end we're still kind of running G-code. This is just a way for us to kind of build a G-code file. So with that, we've never created the mechanism to be able to take a conversational file and import it to simple native G-code. At the end of the day, on the back end, it's really running these cycles. So it's not like we're translating in the back end. So you can't put it out to G-code. To get to our G-code section, what you do have the ability is standard in our G-code. If I had written a program, sorry about that, let me type in a name here, I'll just give it some simple name. we automatically have conversational support in G-code. Program Guide comes standard and has had this functionality for 20 years. So when I get a G-code file, I fill out the page conversationally. I see a cycle. So in the control, I can always open up any cycle, whether it's created from a CAM system or it was physically written at the control. I can open up conversationally. You know, a lot of builders try to leverage what we would call cycle support as conversational programming, and it really is not. Conversational is true conversational. The entire length of the program could have been conversational. Cycle support, standard feature in our control, right in Program Guide. So you get that for all of your CAN cycles. Hopefully that answered your question. This came in here. Let me expand my panel a little bit. Norman Blyer is joining us. Hello, Norman. Before I end, can I comment on what is showing at IMTS, especially what would be new? Absolutely. So those that may not be aware, the IMTS show out in Chicago is going to be happening in a couple weeks, actually in 2 weeks. So it's scramble time. We're going to have 14 tools in our booth. We're going to have a new 828 that supports 2 channels with a spindle, so that's definitely new. We have more demos and new added features on the My Robot functionality. One of the big things we've been doing as of late is handling robot part loading right to the control. So instead of having to have a separate robotic control with its own programs to handling your work loading and unloading or loading, we do that as a separate channel right internally in our control. So all your part programs, loading and unloading, comes to your part programs actually making the parts. So that's some of the new stuff, as well as a whole host of other different things that we're going to have there. There's a question here. Seem to have trouble toggling between incremental and absolute. But when I input my coordinate value, I input my coordinate value, I delete my numbers. Well, sometimes what can happen, Michael, is especially if there was mathematic calculation applied, that one number I input may be then affecting other values. So then by trying to change it back, it didn't want you to do that, primarily because it is the math applied to that field. So kind of what we're talking about here is if we go into our sample, we go contour, I'm in some shape, and I say, okay, I want to now make this a value. It rejects it. I'm feeling that this is probably what you were saying. Well, because that number was highly dependent on all these numbers being calculated. Scenario, yes, I would want to delete the number and flip the panel and put in a correct number. Steve, what does the various key function do? So the various button on our keyboard right next to our increments allows me to create like a variable. So not various, but variable for increment or job. It's not in machine, right? I'm in job. I want to, if I'm moving some defined location, I can jog the mean based on a value, right? So here I have a 10th for 1. 100 is going to be 100 or 10,000, and I can go up. Variable is going to be, so I'm expanding my soft keys over. On Machine Tool, you would do this with the right arrow button generally next to the menu select key. I add settings, and I can now go in and I have an option for variable. So we could create. Now there is PLC logic, so not all builders support it. The simulator does. So I can put a value here. Oh, it should allow me to have the PC logic. It should allow me to then get that variable value. So that kind of comes in. Okay. Always run a program the NC memory, or is it not important? Run a local drive. Are there recommendations regarding the use of a different memory for SAN and local drive? That's a good question. As far as running programs, in our system, you can certainly run from any source. And generally, the only limitation on large files is sometimes the buffer when you're viewing the program in our auto mode. It won't show you quite as much of the program. But that's something that we've made great strides with Operate to be able to support. Some of the older systems and the pre-Operate systems, you lost some functionality. So the core pros run, but they couldn't edit it, or if we did allow editing, simulation wouldn't work. We've really opened up a lot of those restrictions. So we can less where the program resides. With that, though, when using a USB, I always warn people to not get a normal practice for primary reasons. One, it's not a very secure connection. Certainly anybody can come in and pop the thing right out while it was in the middle of running, or jiggling. It's not a great connection. But even more than that, there's a lot of garbage USB sticks on the market. So, hey, I got this free when I opened my bank account, and that's what I'm trying to run my $100,000 machine tool with. So with that said, use it if you get in a bind and you want to run something from the USB, absolutely, but don't make it a normal process. Well, from Robert, how you doing, Robert? What sync thread is a thread repair? Absolutely. Sync thread is our thread repair function. So the old systems, pre-Operate, you used to have to go into the CAN cycle. That's where we had the mechanism to actually align your spindle to your tool, because that's what you're doing when you're doing a thread repair. Now we had it as a function, and the function is within jog. So I expand my soft keys over, and I see the sync thread function. Sync thread tell yes, I want to sync to my primary spindle. Sort of multiple spindle sports if I had main spindle, sub spindle. And then you would physically move the tool over, just like you see in the image, and engage the thread into one of the leads of the thread. Chair, all you have to do is simply hit spindle, and I'll orient the spindle to that tool. Here I can immediately go back in, like, let's say the part program I was running, and the tool's timed. So even if I was in the middle of a production run, I pulled the part out, gauged it, it was no good. I just back in, do this function, and run. Now, certainly have to make sure the part is still in its original location. So either set a new Z tool length offset, or maybe bump stop the part or something. And this is what times the spindle to that physical tool. Great question, Bob. Okay. Well, we got a lot of questions here. Just looking over to see, like, I got everybody. Hopefully I did. All right. Yeah, put one thing for Norman. Another thing that we will be about a little bit at the show is additive machining. And we are going to have, I don't know if we have one in the booth or not. Forgive me. Remember if the DMG machine in the booth is going to be additive machining. I know DMG will have additive machining in their booth running from our control. Additive machining is something we've been doing quite a bit with some high-end builders. So if that's pretty good, I think we're right on the minute here for an hour and a half. Looks like we needed all of it. Thanks, everybody, for attending. I will certainly send out an email. Everybody should receive a thank you email for attending with the link to the recordings. Again, we'll send out invitations for the next one, so hopefully everybody found this helpful, and we can continue this in the future. Great. To end our recording here.